Hey everybody, so we are starting our part 4 of this quarter 3 review. Guys, this starts like chapter 9, which is all about quadratic. There are formulas in here that we just need to know, and of course they tie into things that we've learned before. I'm going to draw our little friend up here. Maybe we remember him, right? Mr. Slope. The eyes represent what a positive slope and a negative sloped line looks like. The nose, the vertical line, is an undefined slope, and his mouth is a horizontal line. That is a slope of 0. Remember, these were special. The tongue and the mouth is the line, the horizontal line, y equals. The nose is the vertical line, x equals. We need to remember this x equals for something, okay? So this first problem that we're getting into on number 28 says, find the equation of the axis of symmetry and the coordinates of the vertex of the graph. Okay, guys, axis of symmetry. So if we have a U-shaped graph, it is fairly symmetrical. There is this invisible line here that cuts it directly in half, and of course, special points sit on this line. One of the special points is going to be the vertex. So it would sit right there. It is the lowest or the highest, depending on if it's a positive or negative function. This particular one would be like an x squared. So it is the lowest point in the graph, the vertex, the very center point. And that axis of symmetry, that imaginary line there that cuts it in half, is the everything reflects. All the points on this side here reflect over it to get you this here. And we had a formula for that. X equals negative b divided by 2a. And b is the coefficient on x. A is the coefficient on the x squared. All we have to do is plug this in, and we can start off with our axis of symmetry. Please, 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 guys, remember, the axis of symmetry is not a number. Okay, we're going to solve this, and we're going to get a number. But it isn't just the number. The axis of symmetry is a vertical line. So a vertical line is represented by x equals. They gave that to us. Sometimes they don't, and you might have to actually type in the x equals. Okay, so please, please be careful. Let's do it. So the opposite x equals the opposite of b, so the opposite of negative 12 divided by 2 times negative 3. So b was negative 12 and a was negative 3. So the opposite of negative 12 is a positive 12. Okay, and then 2 times negative 3 is a negative 6. So x equals this, and x still equals this, and we have to reduce it one more time. A positive divided by a negative will give us a negative number, and 12 divided by 6 is 2. So it is the equation x equals a negative 2. So x equals negative 2. That's bad looking 2. All right, so x equals negative 2. There we go. We have our axis of symmetry. So it is a vertical line. If it was on this one, here's negative 2. It would be this, a dotted line right through here is where that particular equation is going to be centered. And somewhere on this negative 2, the x coordinate negative 2, somewhere on here, up or down, is going to be the vertex. Oh, look what they want us to do. They want us to find the vertex. So we have to remember the vertex is an ordered pair. An ordered pair is made up of an x and a y. Well, we already found the x. If we know that x is negative 2 for the vertex, all we have to do to find the y is plug this negative 2, plug our negative 2 here into the equation. So where x is, we remove the x's. And now we plug in that value, which is -2, which is a -2. Great. So -2 squared, -2 times -2, order of operations. Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. Parentheses say, hey, look at me. And then there is exponents attached to it. So this is what we do first. -2 times -2 is a +4. 4 times 12, or times 3, -12. So this became 4, and you have a -3. +4 times a -3 is a -12. Now we do the next one. -12 times a -2 becomes a +24. And then the -3 comes down. Now we have a -12 plus 24. That gives us 12 minus 3. And 12 minus 3 is going to be 9. So the y coordinate is 9. So this is a quadratic that is centered on its axis of symmetry is at -2. It should be somewhere in here. And we know the vertex is going to be 2, comma, or -2, comma 9. So -2, comma 9 would be where that vertex is. Okay? And let's see it in action now. We look at our next problem, and our next problem wants us to do everything. It says the axis of symmetry is, well, what is the axis of symmetry? It is a vertical line. Notice this is the problem I was just talking to you about from above. Here they gave us x equal. Look, they didn't give it to us here. So we first thing write x equals. And then we have to plug it in. So the opposite of b is a -4. Divided by 2 times a. In this case, a is 1. So a negative times a -4, distribute a -1. You have a +4. 2 times 1 is 2. So 4 divided by 2 is 2. Our x equals 2. That would be our axis of symmetry. So that is the imaginary line here, somewhere in here. I'm just trying to put dots so we can sort of see. Okay, it's going to be centered on this kind of imaginary line. Now we need to find that vertex. Well, we realize from above, again, we have the x coordinate because we had to find that axis of symmetry. We know the axis of symmetry is going to be that line where this vertex sits because it's either the highest or the lowest point. So let's take the 2 and we plug it in. So 2 squared is 4. -4 times a +4 becomes 16 plus 7. All right, so now this is, it doesn't matter how you do it. If you can do it in your head, great. 4 minus 16 plus 7 equals -5. So here is our vertex. It is going to be the point 2, -5. So 2, -5. So there's 2, 3, 4, 5 right there. Let's try to switch colors and see if it's going to cooperate. Now I can get it. All right. So 2, 5, -5. Right there is your vertex. Now use the graphing tool. So in Math Excel, it's easy. We're going to calculate You're going to click on the graph. You're going to click on the U-shaped graph because it's a parabola. You drop a dot where your axis of symmetry is. You still need to find one more point. We need one more coordinate here. So let's find, I always said this is the easiest. 0 or 1. In this case, see the axis of symmetry is not sitting on x equals 0. So we can plug in a 0 for all this. Or we're going to find its y-intercept. So when you plug a 0 in for x, it gives us the y-intercept. So if we plug in a 0, well, the first term goes away, becomes 0. The second term goes away and becomes a 0. And then we have a plus 7. So we always said C is your y-intercept. Whenever you plug in the zeros, makes all that go away. So 0, x is 0, the y-coordinate will be 7. So you go 0, positive 7. And then you can go 1, 2. And now we're going to reflect it back over that axis of symmetry. 1, 2. And so this, I'm going to try to do my best with a mouse. Not so great, but your Math Excel will do it great. U-shaped graph. Yeah, it looks really U-shaped, but it is what it is. Right? Not so bad. We find the axis of symmetry. We plug it in to get the y-coordinate of the vertex, and then we pick one more point. You choose it, so pick wisely. Pick easy numbers to plug in. 30. All right, we're starting to learn how to solve quadratics. Notice that this particular quadratic they give us here, we are missing a term. There's only 2 terms here. This is a special cases, because you might notice, right? We just did this in the last video. We have a minus sign, 2 terms, a minus sign. One's a perfect square, the other one's a perfect square. Okay, so different ways we can solve this. This is saying use the root method. This is the easiest way. We need to solve this equation here, solve the equation to get x by itself, and be careful. So, equations are like scales. We need to go ahead and add 121 to both sides. All right, and these will cancel, leaves us with an x squared equals 121. Now, if we stop and we take a look at this, okay, is x by itself? No, it's not. What do we really have on this side? We have an x times an x. So we have to remember the rules, our rules about radicals. How do we cancel out an exponent? You cancel it out with its coordinating radical. Okay, so this is that invisible 2 sits right here, a square root. And this is not a real world problem. This problem is completely computational. So we have to take into account both a positive and a possible negative result, plus or minus. So we take the square root of one side, take the square root of the other. This cancels this and leaves you with x equals plus or minus. Well, the square root of 121 is 11. It's a perfect square. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. So there we go. Our answer, plus or minus 11. And think about this. 11 times 11 is 121. Negative 11 times negative 11 is still going to give you 121. So that's why we're taking an account into this plus or minus. But on the flip side, if this was a word problem, you have to be careful. If it's dealing with something like time or something like that, then we only need the positive. So we have to use our brains in algebra. We go to look at the next one. It's the same thing as this one, but we've got these fractions here, and everybody always hates fractions. Guys, I've taught you all year long, don't hate fractions, get rid of them. And we know how to do it. We have the tools. We've been doing it for years now. Okay, so look at this. You have a fraction here. How do we get rid of a fraction? First off, let's isolate the term that has the variable in it. Okay, we want to make sure that this is sitting alone. It'll make it easier for us. So this needs to stay here, and we have a negative 8. Well, we have to add 8 to both sides. Remember that equal sign is kind of like a scale. Add 8 to both sides. So that leaves us with 1/8 x squared equals 8. Okay, now we have a fraction. Well, to get rid of a fraction, you multiply by its reciprocal. Just basically take that fraction and turn it upside down. So the reciprocal of 1/8 is 8. Multiply this side by 8. You should already see a trend. Look at this. We're multiplying, we're making a perfect square. We have a square. It's kind of a hint as to what's going on. This cancels and leaves you with x squared equals 64. To get this x by itself, we take the square root of it. And because we're taking the square root of this nice whole number in just a computational style problem, we must account for both the positive and the negative results. All right, this cancels this and leaves us with x. And the square root of 64 is 8. So you have plus 8 or minus 8. Notice I wrote it differently, guys. You can write plus or minus if you have that button when you go to type it in, or it says separate your answers with a comma as needed. So you could do 8, negative 8. Either way works. This way, or if it has that button in your key of solutions. Okay? 32. We're solving these things again. Now, maybe you say, hey, Mr. C, that looks like stuff we did in like the beginning of the year. You have two binomials. I want to box method that together. Well, guys, sure. If you box method that together, you're going to get a quadratic equation. I believe you're going to get x squared plus 5x equals 6. Okay, and it's still saying solve it. They need the solution set. What are the possible solutions? Well, the first thing we did is maybe it also says, hey, Mr. C, this looks like what we did in the last video where we were factoring things. We took that quadratic equation, we broke it apart, and we had two pieces. It left us with two binomials, which we could then box method back together to check our work. Great. If you see that, perfect. It's recalling information we've learned. All you have to do is solve it here, guys. So what they're saying here, this is called the zero product property. You have the product of two things equals 0. So if the product of these two things equals 0, each individual one of those should also equal 0. So you can take these two binomials, split them apart, and set each one equal to 0. And then solve each of these little itty-bitty one-step equations. Subtract 2 from both sides, so x equals -2. Subtract 3 from both sides, so x equals -3. And so what is the solution set? It says type integers or fractions. Use a comma to separate your answers as needed. You must absolutely do this here. We have two separate answers. Our answers are -2 and -3. So just again, this is, we know that it'll be a positive equation pointing up. 1, 2, 3, 4, 5. So our solutions are x equals. This is the x-intercepts of this. You have right here is 1. Let me add another one there. So if this is -1, -2, -3, -4, -5, -6, we know our solutions are -2, so over 2, and then 3. So this is a really tight little U-shaped graph right there. Okay, so we have that. Not so bad. Zero product property. Set each of the products equal to 0 and solve. Here we go again. Another zero product property. So you have an x minus 2 equals 0. And then you have a 3x plus 5 equals 0. Not too bad. All we do is add 2 to both sides. So x equals 2 here. Here you have to subtract 5 from both sides. And we're left with 3x equals negative 5. Divided by 3, divided by 3. So x equals negative 5 over 3. There's our two solutions, 2 comma negative 5 over 3. Again, zero product rule. This is the one, for whatever reason, gets people confused a little bit because you're so used to seeing 2 sets of parentheses. There's still 2 solutions here. You have a negative 9 times, so you have negative 9, there's one factor, equals 0. And then you have a 5n minus 1 equals 0. Okay, so you divide both sides by negative 9. And somebody will go and tell me, oh, there's no solution here, Mr. C. No. Guys, it's okay to have a 0 in the numerator. In your calculator, 0 divided by anything is 0. Okay, you only have a problem is when the 0 is in the denominator. So 0 divided by negative 9 is 0. There is one answer. And then you add 1 to both sides. And you have a 5n equals 1. Then you divide by 5 to isolate your variable. And so n is going to equal 1/5. Great. 35 is now a factoring problem. Okay, so look, our leading coefficient here is 1. We just did that in our last video. So if you need to refresh, go back to the quarter 3 part 3 video. But this is the easy one. When our leading coefficient, when the leading coefficient, or A is 1, it's super easy. C, identify C. So C is 10. B is 7. Okay, we need to find the factors of 10 that when we add them together get us 7. So just list a few factors, 1 in 10. The next one is 2 times 5. And there's all of our factors. When you add this one or this one, does either of these add up to 7? Yes. This set of factors does. 2 and 5. So then we're factoring x plus 2 and x plus 5. Remember, this is not an expression this time. This time this is an equation. So you still have to keep the equal sign. And now, because there's that equal sign there, now we have, just as we did up here, zero product property. Set each piece equal to 0. Sometimes I do it like this if I'm handwriting it to save room. Oh, look, I'm solving it backwards, but I just saved room. Subtract 5, so you have an x equals negative 5. We have to subtract 2 on both sides, so negative 2 is the same as x, or equals x. So there's our two solutions. You have negative 2 comma negative 5. Easy peasy. Same thing here, guys. It's another one. They're keeping it simple on us. We're going to look at this. This is done exactly like the one up here, and I'm going to do 27 while we're still in this factoring mode. Notice that A in this one, A is not 1. So we do have that method that is just a little bit longer. It's the AC method. Again, I do not use any fancy tricks. If you know fancy tricks, great for you. Fancy tricks sometimes get us in trouble because they're easy to make mistakes. Mr. C always follows the rules and does it the right way. All right, so we've identified our C. C is negative 24 and A is 5. So in the AC method, what we have to do is we have to multiply A times C. So negative 24 times a positive 5 is going to be a negative 120. All right. That's a lot there, guys. That's a bigger number. We haven't dealt with one that has a number this big, and we know that b is negative 14. So we need to list some factors of 120. There's a lot of them. Okay, like 2 and 60. You can do all different ones in here. So let's start to 3. 2 and 60 is 1. Just start listing some. You got to start somewhere. 3, so 120 divided by 3 is 3 and 40. Notice that if we are adding these together, we have a negative, or our result needs to be negative. So it means the bigger numbers have to be the negative ones here. These are not even, when you add these, you're not even getting close to this. And you're going to keep going and keep going and keep going. 4. Okay, so what? 120 divided by 4 is 30. And then 120 divided by 5 is 24. I'm just getting lists of them, man. 120 divided by 6 is 20. So 6 and 20. Knowing that these are all supposed to be the negative. Now I just came across one. Look, if we add these two together here, we get that negative 14. So 6 and negative 20. We are ready to start to do this. Remember, the AC method is different because we use these numbers this time to rewrite. We use these numbers to rewrite that middle term. And then we factor by groups. And minus 20x plus 6. Oh, I'm doing the common mistake that all of you guys do. And then we make we put our answer in and we're wrong. Look, our variable is m, not x. Have to be careful. It happens to the best of us, guys. And the last term was minus 24. All right, so now we have two different parts. Okay, we can factor this. We're factoring by groups. There's one group. Here's one group. The whole purpose of this is to make it into something easier for us to look at. Look at the coefficients in the first term, a 5 and a 20. The smaller number is 5. Does 5 go into 20 evenly? Yes, so you can pull the 5 out. Do they both have an m term? Yes, they do. The smallest degree is m to the first power. So that can come out. We write our parentheses. And then we're dividing this whole thing by 5m. So 5 divided by 5 is 1. M to the second power divided by m is just an m. And then negative 20 divided by 5. Negative 4. M divided by m is 1. Do the same thing here. Does 6 go into 24 evenly? Yes, it does. So 6 can come out, and that is a positive 6. Do they both have an m term? They don't. So you can write your parentheses. Now you're just dividing all this by 6. So 6m divided by 6 leaves you with just an m. And then you have negative 24 divided by 6 leaves you with a negative 4. Look, we did it right because our result that are in the parentheses are the same. So here's a shortcut that is perfectly fine to do at this point in your algebra career. You have 5m plus 6 times m minus 4. Remember, there was an equal 0. And since this is the zero product property, you have to set each piece equal to 0 and solve each one separately. So you can just divide that there. Here's one equation to solve. Here's the other equation to solve. So you subtract 6 from both sides on this one. then you divide by 5, and you divide by 5. So m equals, here's one solution, negative 6 over 5, and that does not reduce. On this one here, you have to add 4 to both sides, so m equals 4. Here are your solutions, 4 and negative 6 over 4. All right, go ahead, guys. Please, please, please get busy. Do this. There will be one more quarter 3 review, and then I will have a final review that's put up of particular problems that are very important. They're like the key concepts of what we're doing. If anything else that you do all year long, you need to make sure you know how to do those problems that will be listed in the very last video I give you. All right, please subscribe. You're going to need to know this. Subscribe, like the video, share it, because you're going to need it. All right, have a good one, guys.